All right, so again, you need these two formulas, right? Volume of a cylinder, volume of a sphere. What you see here is the reference sheet you will be given when you take this. Something else we talked about last time was you needed 360 degrees in a circle, right? 180 degrees in a triangle. I want to talk about this little fact tomorrow, talking about radians and degrees. Just one little quick reminder. It's been a minute since you've done something like that. All right, so anyway, cylinders, example one. The company is designing packaging for a food product. The packaging is in the shape of a right circular cylinder shown above. The height of the packaging is 9 centimeters. The volume must be exactly 144 pi. Now that freaks everybody out. The 144 pi freaks everybody out. You just leave the pi alone, leave it there. What is the diameter of the packaging in centimeters? So first of all, what's the volume of this shape? Well, the formula is this right here, right? Now, on another question on here, you're going to have to use the following fact. How do you come up with the volume of a cylinder's formula? Where does it come from? Well, isn't the base of a cylinder a circle? Right? So that pi r squared is the area of a circle. And so imagine like you have a bunch of pennies you're trying to stack up, right? Or quarters. If you want to find volume, you'd stack up a bunch of them. But if you want to talk about area, and we think of a quarter as being two-dimensional, even though it's not, that's one of them, right? But then we have to figure out the volume by multiplying by how many we stack, right? So that's what's happening here. You take the area of the base times the height. And that's generally how you find the volume of any kind of prism, or in this case, a cylinder. Even though it's not a prism, it has two bases that are the same. Now, it doesn't work for a pyramid, right? Because they don't all stack up the same. It comes to a point. Same thing with a cone. But it's the area of the base times the height. Imagine stacking up that many circles. That's where the volume comes from. All right, now they tell us a couple things here, and then we're supposed to solve for something else. They tell us the height is 9. They tell us the volume is 144 pi. And this whole thing fits right in with what we did last week with rearranging formulas. We're going to solve now. Now, from this equation, we can figure out the radius, but what's the question asked for? Diameter. All right, so here we go. If we want to isolate r squared, you would do a couple things. You would divide by 9, and you would also divide by pi. When you divide by pi, those cancel. Keep in mind that's equal to r squared. That is not the radius. So how do you solve it from here? Square root? Yeah, let's go. How do you square root a fraction? Square at the top, square at the bottom. Okay, 16, right? There you go. So 16, either way you end up with 4, right? That's your radius. Is that your answer? No. What's your diameter?
Double?
Yeah, diameter is double that, right? So this is actually your answer, right? So in that case, they gave us the volume and we had to solve for one part. Okay, example 2. The twist. Sometimes there are two cylinders. This one is similar to a rearranged formulas question. A grain silo in the shape of a right circular cylinder has a volume of 256. So we got a volume of 256. What's the volume in cubic yards? Same thing. Of a second grain silo that is 3 times as tall and 1/2 as wide. Right? This is kind of like when we had to plug in numbers for our own. Do you remember that? All right. Keep in mind that the volume of this, pi r squared h. What's the volume in cubic yards of a second grain silo that's 3 times as tall and 1/2 as wide? Now, you can't just plug in any two random numbers here because you have to make it so that your volume does end up being 256. So let's pick one of the variables. Give me a number for the radius. Anybody? 2. All right, so what we're going to do here, I'm going to set the radius equal to 2. We're going to say 256 is equal to pi, and then we're plugging in 2. We can only choose one because they work together as a pair, right? The radius and the height have to work together at the right rate that spits out the volume 256. I can't just pick any two numbers, right? I have to get 256. So anyway, here we go. 2 squared is 4. And then if we wanted to solve for h, it would end up being this. You'd have to divide by pi, but you'd also have to divide by 4, both of those things. If you do that, I know the pi is going to be funky on the bottom, but that's okay. You can take 256 divided by 4. You can simplify that and put it in the numerator. Somebody want to help me? I think it's 64, right? Yeah? Okay. So your height is 64 over pi, which is funky, but that's okay. Let's just keep it there. We're going to remember it. Now, that being said, it says, what is the volume in cubic yards of a second grain silo that's 3 times as tall and 1/2 as wide? So now here's our new cylinder. It says the radius is 1/2 as wide. So that means the radius has to be half as much, right? Okay, so that means our radius is going to be half of that we chose up above. We chose 2. So our radius on this one's going to be 1. What did they say about what the height has to be? 3 times. So the height is 3 times as tall. So it's going to be 3 times this. Now, how do you do that? What's 3 times 64? 192. All right, so this will be 192 over pi. And while this freaks everybody out, here's the simple thing that happens right away. What do you think happens on the right-hand side with the pi's? They cancel. One's on top, one's on the bottom, right? So then 1 squared is what? 1. And 1 times 192? Yep. There we go. So we kind of arithmetized that one. Here's the whole page right there. Kind of funky. We had to choose a radius, but we couldn't choose the radius and the height because we had to figure out a combination that would give us a volume of 256, right? But once we arithmetized that one, we could solve for the height, and then we could apply the situation that they asked us to do. Let's flip this thing over real quick. Couple notes on these that I want you to try out. Number one's kind of funky. It says, what is one possible integer value of the volume of the jar? Now, what they're saying is the internal radius will be between 2.45 and 2.5. You have some options to choose there, right? It can be as low as 2.45 and the radius can be as high as 2.5. What they're saying is, what are the possible values for the volume? And they say you have to answer as an integer. What's an integer mean? A whole number, right? So you need to figure out what are possible values in terms of whole numbers. There are a ton of possible answers. Okay. Now, for number 2, it says, what's the volume of the rock to the nearest cubic inch? Let's read through this. A container in the shape of a right circular cylinder, so like this, right? Filled with water to a height of 20 inches. The base of the container has an area of 80. This is what I was saying earlier. The volume formula means the base, that's this, the area of the base times the height. You need to know that for number 2. So now below it says the base has an area of 80. When a rock is dropped into the container, the height of the water rises to 22. So we drop a rock in, and now it goes up. What doesn't change? The area of the base, right? That doesn't change. The only thing that changes is the height, right? So what we need here is, what is the volume of the rock? Well, the change in volumes is only because of dropping the rock in the water, right? So in order to answer this question, you need to think about this. What's the volume when the rock is in there? And then subtract the volume before the rock, right? Volume of the rock in there, take away the volume before the rock, pre-rock, if you will. I'm not talking about Dwayne Johnson, not that rock, if you smell what I'm cooking, okay? Let's look at number 4. Let's skip over number 3. Number 4 says, what's the volume of this pill? I said you needed 2 formulas at the beginning of the lesson, right? Cylinder and sphere. What you have here is a cylinder in the middle. That's this. There's your cylinder. And then the rest of this is a sphere that got split in half. But there's 2 halves. So what do we need to do? We need to use both formulas. You need to do, what's the volume of the cylinder in the middle? And add to it the volume of the sphere on the outside. The thing with the volume of a sphere is you only need one input. The only thing you need to plug in is the radius. Okay, so that formula is 4/3 pi r cubed, if you didn't write that down before. All right, I'm going to try out those 4, and then we're going to move on to something else here in about 10, 15 minutes, something like that, maybe 10 minutes. Okay.